Okay, now we are recording. Oh my gosh. Okay, it wasn't, I only missed 15 minutes. Thank you, Ronald. Okay. We're taking, okay. So remember how in 1.8 we were talking about all these different models? Like, how do I know how to create a model? Like, you're telling me all this information. Like, what do I know? How do I figure this out? In this chapter, they really break it down. So first we're going to choose the variable. Right, we're going to identify the varying quantity. Sounds like kind of like something like a dependent variable, independent variable. Probably the independent variable is going to be the varying one. Right, in the problem, oh, I even wrote independent variable, getting ahead of myself. And give it a name, such as X. In the last problem, it was time. I would probably call it T. That's just me. But yeah, so find something, the varying quantity, right? Like I can vary, time is a very common one. It's another one. Is distance? No, time's a pretty normal one. All right, cool. And so then we're going to translate words to algebra. Right, so express all the quantities given in the problem in terms of the variable x. If we're talking about 5 times or like 5 miles per hour, but I started 20 miles away, something like that, right? I know that 5 miles per hour, I'm going to multiply by my hours and stuff like that. And then we're going to set up the model. So we're going to smush everything up together. Like I was saying, when we translate words into algebra, this is most likely the second step is going to be where we get those linear models. And then I'm going to put them into like one big model, right? So I'm going to express the model algebraically in numbers and pluses and symbols as a function of the variable x. All right. So this problem is worded really confusingly, but we'll get through it. So Marion inherits $100,000. So she invests it into 2 one-year certificates. So in 1 year, it pays out. So she's $100,000. She's going to invest all of it. She's like, I got my stimulus bill. I don't need to save any of my $100,000. I'm going to put it all in, right? So one of the certificate pays 6% interest, and the other one pays, I forgot to include this one, 4.5% interest annually. This does take a little, there's not like, oh, you do this, 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 other than like kind of the vague steps we're given, right? So, kind of how I also like to start out before I choose a variable is kind of like make a word equation. So she inherits invests, blah, blah, blah. So let's call all of her money like M or something, right? So she's gonna have money from the 6% cert plus the money that she has from the 4.5% cert. Oops. And we'll talk about how to figure out the percentage thing in a second. All right. So, the money that's in these after a year depends on how much she put in the beginning, right? So let's call step 1 is to identify our variable, right? So we're going to say let X be the amount in the 6% account, right? So I'm putting X amount into there, and then I'm going to put, that was in the problem. I wrote simple. I don't know why that was in the book, but it was supposed to be 4.5. So that was supposed to be written in the problem. So one account has 6% interest, meaning if I put $10 in, I'm going to get, well, not $100 in, I'll get $6 back out. And if I put $100 into the 4.5%, I'll get 4.5 comes out. Okay. So we're going to let X just be the amount in the 6% certificate. So now in 2, it says to translate words to algebra. So if I'm putting X in the 6%, how much is going to go into the 4.5? She only has 100,000. If she has $100,000, she's investing all of it into these 2 accounts. She's taking X of it into the 6%. How much is going into the other one? Yeah, $100,000 minus that part that I've already put in, right? She only has $100,000 and she's putting it all in at once. So I'm just going to take that X amount away. So she invests 100,000 minus X dollars into the 4.5% certificate. Okay. Is everyone okay where I got 100,000 minus X? Okay, cool. So, we're looking for a model for the total interest Mary earns, right? So if you don't know how interest works, if I put in $100 into like the 6%, I'm going to get, it's a percent, right? So I need to make percents into decimals. So I would have like 0.06. That's 6% times, let's say, that initial 100. I would get $6. That's just pure interest back out. Okay, so that's how interest works. I don't know what certifications are 6%. That's wild. Okay, so now knowing that, and now knowing that I have, oopsies, we're calling M our interest, Mary's interest. If you want to call it Y, it's not a big deal. So it's just 3, making our model. I have my money from my 6% cert. So I know, right? I think my savings interest is like 0.1%. It's ridiculous. What do we think? How do you think we can represent the interest made from the 6% certificate if she invests X amount of dollars into it? Right? 0.06 X. Right? So this is the interest of the 6%. So I just took my interest and I multiply it by, no, because it's 6%. Think of it as 6 cents for every, 6 cents for every dollar, and she's putting X amount of dollars in it. So I need to multiply it. I'm not adding it, or else I'm only going to get, I put in $100,000 into that one. I'm going to get $100,000.06. That doesn't correlate to interest. Interest is multiplied, not added. Okay. I think, Griffin, if you're saying also plus X, you're thinking of what we're going to get back out. Yeah. Yeah, but we're just doing total interest. So pure interest, not, what is that called? Principal and interest. I worked in the mortgage industry. Okay, this chair is so squeaky. Okay, cool. So Griffin was talking about if we were talking about not just total interest, that's when I would do like 1.06. So that principal amount that I put in, I'm still going to hopefully get it all back, plus an additional 6%. But that's not what we're talking about. That's why you need to read the questions very carefully. All right, so 0.06x is my interest for my 6%. What do you guys think it's going to be for our 4%, 4.5% certificate? So I took my interest and I multiplied by the amount that I put in. Careful, I'm not putting X into the 4.5%. Yeah. So I'm going to take my interest. Oopsies. So careful, it's 4%. Yeah, 0.45. And then 100,000 minus X. And that's going to be the interest of the 4.5%. Sir, okay? Yeah, other way, yeah. $100,000 minus X. Okay? So that's our equation. If you wanted to like multiply through the 0.45, you could. You don't need to. But if we did, what would we get? Actually, that might help. You'd get 0.06x. What, 0.06x plus 4.5% of 100,000 is 4,500 minus, don't forget that negative, minus 0.045x, which is going to come out to 45 minus, no, not minus, plus 0.0. Why is my pen not working? There we go. Okay. And that's just after distributing. It's helpful to use it simplified just because we can get to the sometimes what we ever need to do in the next step. All right, coolio. So this is our equation now. Put a big M right here. So if Mary's total interest is $5,025, how much money did she invest in each certificate? So we know this equation. Slash function, it's a function. And we know that her total interests is that much. So is that an M value or an X value? It's an M, right? So we know M is going to equal 5,025. So I want, what do we want back out? Careful. We want to know how much you put into each certificate. So we want X when M equals this amount. I'm just teaching you this as like a tool that I do. And we also want 100,000 minus x when m equals 5,025. Because it asked for how much she put in each certificate. They could have asked how much did she put into the 6%? And then you just need X. How much did you put into the 4.5%? But now it just wants each certificate. So we need to have two values as our solution. Okay, so we're going to set our equation equal to this number. Is anyone taking like a finance or accounting class this semester? My accounting class was really fun. I love my professor. It was really hard. That's coming as a math major. So it's gonna give me 525. I could have easily done that in my head. 0.015x. And then I'm gonna get x equal to 35,000. Was it hard? My also accounting class was like a 3-hour evening class once a week. Yeah, it's so hard. I think I got an A minus. We had minuses where I went to undergrad. Oh my God. Accounting is okay. I think about FIFO and LIFO all the time. Okay. Actually, I'll take that back. I really enjoyed accounting. It was just still hard. Okay, so I got 35,000. What do I do with that number? Is that my final answer? Okay, enough accounting talk. But microeconomics was my worst class. Yeah, we also need to find 100,000 minus x. I found x, and now I need to find 100,000 minus 35,000, which is going to be 65,000, right? So we're going to say she invested 35,000, just put a little K right there, in the 6% cert, just being really detailed right now in my answer, and 65 in the 4.5% cert. Beautiful. Right? Don't forget your units. Remember in dollars. That's a unit. And so on. Okay. Does anyone have any questions about this problem? Or anything they want me to reiterate? Okay, clear. So now we're going to talk about concentration. So this might be kind of confusing if you've never taken, what do you mean every problem? Like 1, 2, 3, this is my variable, math to words. I don't expect you to like write on your homework. It's just kind of a helpful tool for you to find these models. I would like to see obviously work. So like if you just like, again, just spit out this equation down here, I'm gonna be like, how did you get that? But if I see that you kind of are like, oh, this is my interest here, this is my interest here. Kind of similar to when you guys were finding the area of that garden for the farmer. Like I kind of need to know, be like, oh, my perimeter is this much, and this is what my perimeter is, so I can solve y this way. This is more of like steps 1, 2, and 3 are more helpful tools. Kind of similar to when we talked about factoring and doing the AC method. You don't have to do that when you're factoring. It's just a helpful tool. Okay. But I do need to see some work other than here's this equation. Does that answer your question, CJ? Okay, cool. So, if an amount X of a substance is dissolved into a solution of volume V. So anyone ever makes simple syrup? It's just sugar and water. So if I pour X amount of grams of sugar into X amount of grams of water or volume of water, I would want to know the concentration of that, right? So we call the concentration. Do you guys ever play the game Concentration 64? No repeats or hesitation. Game slapped at swim meets. Okay. So we call this concentration. It's like I will start, you will, I forget the rest of it. I always lost. Okay, so I'm gonna have X is the amount of substance I'm putting into my solution divided by the number of, you will follow. Okay. Into the volume, right? If you've ever taken any chemistry class, this is like a common, you like dilution something. If I need to dilute something, oh my God. Okay, everyone. I knew I shouldn't have mentioned that game. If you're like trying to dilute something, this is a problem that you've seen before if you've taken any AP chemistry or college chemistry course, I believe. Don't ask me about bio. I didn't take that class. So for example, if I take 10 grams of sugar and I dissolve it into 5 liters of water, my concentration is 5 grams. Sorry, not 5 grams. 10 grams in 5 liters, which is just 2 grams per liter. Alrighty. So that's how we get concentration, just like some division. And we're assuming that the sugar is dissolved into the 5 liters. We're assuming that sugar's volume or displacement is negligible. In this case, it's not always going to be like if I added liquid to liquid, like coffee and cream. So I didn't add anything to the bottom now, but I'm warning you that that might be something that's going to affect your volume later on. Okay. And then I get grams per liter just because that's kind of how it's happening. I'm telling you that like the 10 grams of sugar isn't changing the volume of the water at all. So I'm still just gonna have 5 liters. Say if I put 2 cups of coffee and 2 cups of milk together, my volume's now 4 cups. And that changes, but my concentration is like 50% or something like that. Okay. So the main example here is that the manufacturer of soft drinks advertises its orange soda as naturally flavored, although the soda contains only 5% orange juice. All right, 5% orange juice. I'm gonna highlight that because that sounds important. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% orange juice. Whee! The manufacturer has a 900-gallon vat of soda. Oh, so much. And decides to add pure orange juice to the vat. We're going to construct a model that gives a fraction of mixture that is pure orange juice. Okay, so I have substance that is in the solution over all the solution. So I don't want to go too fast because I want to, yeah. So let's just go work through those steps, kind of what we were given before. What's kind of our varying or independent variable? What can I change in this situation? Right? Orange juice, pure orange juice, right? So let's just say let X be the amount of pure OJ. It's quite fitting that we're typing in orange now. Right? So then 2, we're going to put words into with numbers, right? So I'm adding X gallons of orange juice to my 90 gallons, right? So since X gallons is added to what is going to be our total volume after I add in those orange juices, pure orange juice gallons? So I start with 900 and I'm pouring X amount in. That's if I pour in 10, but I don't know. Yeah, 900 plus X, right? I'm adding them together. It's kind of what I was saying earlier about we're adding it in, right? So I'm just putting it on additionally into it, right? So then we have that initially there's 5% orange juice in the 900 gallons, right? So we have so how much OJ is in the original 900 gallons? Yeah, 5% of 900, which is going to give me 45 gallons, which is 0.05 times 900. So it's a percent here instead of like we talked about earlier, grams over liters, because both things we're adding and have the same units, they're gallons. All right. So out of that 900 gallons, I have 45 of them that are pure juice. I don't even know what's in the rest of them. I don't care. Okay. So we want to say after adding X gallons of pure OJ, we want 10%. Oh, after adding, oh wait, hold on. Not we want. So I started off with 45 gallons of pure orange juice, right? I got that from 5% of 900. So after I pour in the X gallons of OJ, how much pure orange juice is going to be in there? 45 times X, 45 minus X, 45 plus X. What do you guys think? Need some communication. So if I, yeah, plus X, right? I'm still adding the gallons to it, right? We even said it after adding X amount of gallons, we'll have 45 plus X gallons of pure OJ, right? It's not always going to be plus X, right? I could think about of somehow removing some of those. That would be like minus X. Alrighty. I don't think it'll be times X much, which is kind of confusing since there is a percentage, but it's okay. Alrighty. So now I have 45 plus X, I have 900 plus X, 945, I have X. So I now need to come up with a model that gives a fraction of mixture that is pure orange juice, right? So remember concentration, you can also think of it as fraction of the thing that is that other thing. So let's call it P for pure orange juice, right? What do you guys think this equation is going to look like? After I've poured X amount of gallons of pure orange juice in it. It's a concentration, so I'm going to have a division, right? And it's asking about the mixture that is pure orange juice. So I'm going to have my number of gallons of OJ. And I'm also going to have my total number of soda, which again, remember the soda includes the OJ. I really like these word equations where instead of putting numbers here and here, the numerator and denominator, I'm putting words. That's really helpful to me. If it's not helpful to you, flush it out of your mind. Okay. So what will represent the number of gallons of OJ? Sorry, after I've like the total number of gallons of pure OJ in the soda. Not just X, that's how much we're pouring in. But now this is the concentration of, after I've poured an X amount of it, how much is like all there? Remember, I started out with 45. And then after I add X gallons, we'll have 45 plus X. Should I put 45 right here? Yeah, I want to put 45 plus X right there. Because that's the total number of gallons of orange juice that are going into the soda after I poured in X amount. All right, and what about the total number of soda that includes all this orange juice that I've put in? What's that going to be? If I start out with 900 gallons, what's going to be, yeah, 900 plus X. That's why we can't just like double the amount that we've put into the of OJ. Like, oh, if there's already 45, add another 45. Well, that affects the denominator too. So I need to add a little bit more than you're thinking. All right, so how much pure orange juice, and that's our equation, right? So we can even call it like P of X 45 plus X over 900 plus X. Does anyone have any questions about this equation before I move on? Because you guys aren't talking a lot. So I want to make sure that you're understanding this because this is the problem that everyone struggled with on the exam last year. So you will be seeing it again. It smells like cookies in my house. So any questions? Okay. And if you're typing questions while we're moving on, I will answer them. So how much, that's our equation right there. How much pure orange juice must be added to the mixture to satisfy the 10% rule? Okay, thank you, Jaden. So 10% rule, right? I want my concentration, right, to be 10%. So we want to figure out what X is, right? So remember, we're doing percent, so we need to move our decimal over. And then We know how to solve things like this. I want to multiply 900 plus x onto both sides. These cancel out because anything over itself is just 1. So I get 0.1 900 plus x equals 45 plus x. I'm going to distribute this now. So 10% of 900 is just 90. I move the decimal over. Plus, don't forget to distribute it to your x. 5 plus x. So great. Now I have everything on one line, one playing field. I got everything out of the denominator that I needed to. So now I'm going to put all my x's onto one side and all my other numbers on the other. So I'll get 45. And remember, this is like a 1. So like 1 minus 0.1 x, which is just 0.9x, right? Yeah. Careful, that's 90%. Wait, that's what we wanted. Yeah, almost put 9%. Great, and then I'm going to divide each side by 0.9. And 45 is divisible by 9, so this should be, yeah. So x equals 50 gallons. Gallons. Alrighty. So x equals 50. Right, and how, what is that beside 45? There's all to 45s, like this guy? This one, that's a 1. Very poorly written 1. Plus like 1x. I was just kind of saying that there's a 1 in front of x. Did that answer your question, CJ? Yeah, I just put a 1 in front of x just so you would like see that it's like going to be like 1 minus 0.1. Okay, right. So now it's going to be 50 gallons. That's what we're going to add, right? You might think of like, oh, if I'm at 5% with 45 gallons, I'll add another 45. But, 45 divided by 0.9. But that's incorrect because that is going to change the amount that you spend, right? So like we can also check, right? If I add 50 gallons, it's going to be 45 plus 50, 900 plus 50. So that's going to be 95 over this amount. Oops, I went 50. Why did that not erase all the way? There we go. I meant 50, not 500. There we go. And that is 1 over 10, which is the same as 10%. Right? So you can always check your work with these, which is awesome. And you should check your work, especially on your exams. You guys get all day. Take the 5 seconds extra to check. All right. I've seen a lot of times people just like, oh, it's 45. But if I add 45 plus 45 over, they forget that they're adding that to the volume too. So I get 90 over that, and that is not 10%. It's kind of like the equation of idea that like, oh, if you pay people are making $7.50 minimum wage, $15, you can change the business expenses 2 times that. No, because of how concentration works. Okay, so how are you feeling about this orange juice problem so far? Thumbs up, thumbs sideways, or thumbs down? These problems are difficult, so I expect like a lot of sideways. I'm saying you just can't add, like, it's a common misconception when I see these problems. You're like, oh, if I have 5% orange juice and I need 10% orange juice, well, I start with 45 gallons, so I'm just going to add another 45. That's twice as much because 10% is twice as much as 5. But they're not thinking that I'm adding that to my denominator as well. I'm like including that in like what I'm in here too, not just this top part. So that's why you can't just expect it to be twice as what you think. Is that what your question was, CJ? Yeah. It was just the biggest mistake that I saw on the exam last year, and I don't want you guys to make that same mistake because you guys are smarty pants. All right, cool. 520. Is this her last problem? Okay, coolio. We'll do this, and then your exam will be next Thursday. Alrighty. So Al paints with watercolors on a sheet of paper that is 20 inches wide by 15 inches high. Okay. 20 inches wide by 15 inches high. So let's draw this beautiful masterpiece. Okay, act like that's, so what is that, 15 and 20. He then places this sheet on a mat so that a uniformly wide strip of the mat shows all around it. Uniformly just means the same, like a uniform, everyone wears the same thing. So now I'm gonna add this like mat, make a cute little border, if you will. Like a picture frame. Okay, act like this is like all the same, right? Usually in geometry, we like draw a line through it to say that these things are the same. All right, so I want to construct a model that gives the perimeter of the mat. Okay, so this is kind of similar to when I asked you guys about the volume, except that one was like, here's the model, explain it to me. And you guys were like, here's the model again. I was like, okay. No. So now we're asked to construct a model that gives the perimeter of the mat. So what kind of shape is our mat? Is it a circle? Is it a square? It's a rectangle, right? So we all know that the perimeter of a rectangle is 2 times the length plus 2 times the width, if I'm using all sides, right? So what is going to be, right, our length? I know that it's at least 20, and then I'm adding how much onto either side. So here's my length. Oh, I guess this is my width. It feels weird. I feel like wide is this way, length is this way. It doesn't matter. That's gonna bug me. Now we're gonna change that. No, we're gonna keep it. Okay. So I know at this point it's gonna be 20. So it has to be at least 20 because I want it to, I'm not gonna put a painting on top of a mat that it's gonna be smaller. That's silly. But what about these extra little sides right here? What's that distance? So this distance right here is 20. And then what about these extra little distances? Each one of them is X, right? And I have 2 of them. So what am I going to do with that X? And that 2. Right, I have 2X. Am I going to multiply that by the 20? I have too many marker colors. Right, and that's X, and that's X. I'm going to add it, right? So my length is going to be 20 plus 2x. So x right here, this is kind of where you kind of need to do, you don't, following 1, 2, 3 steps is helpful, but you're like, what is x? I don't know what I'm changing. What do you guys think exit represents after we just found what the length is going to be? How can I like verbally say what x represents here? It's the width. I think it's not the width of the mat. Yeah, the mat's extra leg. So let's go wide strip the mat shows. So x represents the length of the uniform strip the mat shows. Okay? So it's that little extra bit. If it was the width of the mat, it would be a lot more. Okay? So now let's actually find the width of the mat, right? So L was 20 plus 2x. W is going to be 15 plus another 2x, right? What's that? W equals 15 plus 2x. Okay, great. So I have my length and my width, but I was asked to give the perimeter of the mat. So I'm going to smush them all together. So I'm going to say the perimeter is going to equal 2 times the length. So 20 plus 2x plus 2 times 15 plus 2x, right? And then to help myself out, I'm going to distribute. So 40 plus 4x, 30 plus 4x, and that's going to give me a perimeter of 70 plus 4x. And again, x is that extra width. Okay? Is everyone okay with how I got this mat? Oh, yes, not 8x. Sorry. It's going too fast in my head. Alrighty. So that's our equation. We're now asked if the perimeter of the mat is 102 inches, how wide is the strip showing around the picture? So perimeter of the mat is 102 inches. So is X 102 or is P 102? Yeah, P is 102. Right, and we know the perimeter is this equation, so we just set them equal to each other. And then solve. So 102 minus 70, what is that going to be? 32 equals 8x, and then x equals 4, right? So I would say 4 inches. I believe inches was our unit. All right. How are you guys feeling about this section? 2.6. Thumbs up, thumbs sideways, or thumbs down? Because now we're done with this section. Okay, good. It's definitely tricky. Don't forget that I have office hours before class every day. I also have MTC hours on my syllabus. So if you have any more questions about this, and if those times don't work with you, email me, we'll set up a time. Alrighty. Okay, cool. So now we're going to start on to 2.7 because this is kind of connected to the exit slip that we talked about last class, right? So I know we only have March. a few seconds, 10 minutes. But so this is where lines meet. And we've kind of already been doing a little bit of that when we talked about that pool problem, right? So in the last section, we said to find intersection of two equations, we set them equal to each other, right? Or like my output is this, right? If the perimeter was 102, I just put 102 in for P. You don't really think of those as like two lines intersecting until we showed the picture when we talked about the pool. So if there are lines, and by lines, I don't mean like squiggly lines, I mean like a line is just like a straight line. Right, so y equals m1 plus x plus b1 intersects y equals mx m2x plus bx at the x value where b1 plus m1x equals b2 plus m2x. Right, so I'm just putting the two y values, they're equal, right? So they're going to smush together. Y equals y, put them together. Okay? And I know I messed up the order of that, but it's okay. So how many points of intersections will two lines have? A lot of you guys gave me some interesting responses, but I want to kind of ask you guys again. How many points of intersection will two lines have? Remember, two lines are straight lines. Ronald says once. Anyone else have any options? We talked about, don't forget we talked about parallel lines the other day. Ooh, Abby, infinite. And then the other option is 0 times. All of those are correct. So 0, 1 are always. So for once, we're pretty used to seeing that. Let me draw my axes. Okay, don't come for me. These are bad. Copy, paste, paste. Okay. So once we think of just like two arbitrary lines that don't really have anything in common, right? Like these two guys. I'm gonna do that a different color. Ah. Those intersect at one point. What's a situation where two lines intersect at infinite points? Abby, do you know? Right, they're overlapping. They're actually the exact same line. You're like, well, Mackenzie, like, but remember, I can write the same line using different B's and M's the same way. Let me see. I need to find my marker that I was using. Oh, right. So they intersect once if there are different slopes. And they're going to be intersecting infinite amounts if it's same slope and y-intercept, which is the same line. But what if they have the same slope and different y-intercepts? We saw that a few classes ago, I think even last class. Are these two lines ever going to intersect? Yeah, they're parallel. They're never going to intercept. So same slope. Ooh, but specifically with different y-intercepts. So those are my three options. Someone told me 3, which I thought was Interesting, because I don't know if they meant there were 3 options or if they just meant it could intersect 3 times. So intersect once is kind of what we're going to think about most often, just 2 arbitrary lines. But then I have the option of where they're parallel and they're never going to intersect. And I have the option that they're parallel and they have the same y-intercept, which happens just to mean they're the same line. Okay. And it's not always that obvious because remember we have 3 different forms of writing our line. Think about what those 3 forms are called, because that's going to be your exit slip in like 5 minutes. All right. So we're not always going to be given y's. We might be given f and g, especially when we're talking about 2 different lines. It's going to be easier for us to write it f of x and g of x. All right. But we're still talking about lines. So if f of x equals 5x minus 8 and g of x equals 3x plus 2, find the point of intersection between f and g. Right? If they have the same, if they're going to intersect, there's going to be that point x, y. And they're both going to have that point. So they're going to have the same y value and x value. Or similarly, I'm going to have f of x equals g of x and then go on from there, right? So 5x minus 8 equaling 3x plus 2. So I'll get 2x equal to 10. So x equals 5. But I want to find the point of intersection between f and g. So far, I just have x. So what should I do next? Plug it in. Does it matter if I plug it into f or g? Which one should I plug it into? Yeah, it doesn't matter. Right? So we're going to plug x equals 5 into either f of x or g of x. If you wanted to do both, just to double check yourself, that's a really great option. Let's do g because I like the smaller numbers. So we're gonna have 3 times 5 plus 2. So 3 to 15 plus 2, which is gonna be 17. So the point of intersection is going to be, what is it? 5, 17. Alrighty. So I think this is where we're gonna stop for the day. The next problem is really cool about buying a car versus like an electric car that costs more, but it only needs so much gas versus something else. And it's really cool. And we talk also about supply and demand. All right, so let's do our exit slip. Okay. And your teacher question of the day is going to be, what are the 3 forms we can write the equation of a line as? I don't think that's the English way of writing that, but whatever. Alrighty. So what are the 3 forms? Don't give me the forms, but their names. I want their names. And then if you guys have any questions about today, I'll be here for a little bit. But yeah. Of course, you're welcome.
I have a question. Socratic, or not the Socratic, sorry, the Cengage online still doesn't work for me. And their support never got back to me.
Oh my
I'm
gosh.
2 weeks of homework now because I just haven't been able to finish it.
Okay. They didn't get back to you. So it's like you're opening it and it's like you like go to the oh yeah, thank you, Griffin. What is the problem again? Sorry, Clayton.
So every time I go in and try to answer a problem, if I click next question or any other problem on the online portion, nothing happens, nothing's there at all. Just all goes away. And then if I try to go back to the first question that I was able to do but not submit, it goes away as well. And there's just no problem anymore.
Okay. And Cengage never got back to you.
No,
That's annoying. Okay. Have you checked on this week's homework? If that's happening?
I have, and it's still happening.
Okay. Let me reach out and I'll give them your account name and hound them on it, and then I'll give you extensions once everything should be working.
Okay, thank you.
Yeah.
I'm getting the homework on Blackboard done. No problem. Not able to do anything else.
Yeah. Real quick, have you made sure that you have paid for access for Cengage?
Yeah. I
Okay.
have access. I mean, I
Okay.
still use the textbook and everything just fine.
Oh, that's weird. Okay, yeah. I will email them. My computer is opening and I will let you know the progress on that.
Okay, thank you.
Of course. Have a nice day.
You too.